Today we are going to talk about the Lineweaver Burk plot. And the Lineweaver Burk plot is basically was devised because of the fact that the Vmax cannot be determined directly from the Michaelis Menten graph, because the horizontal line present there is not exactly horizontal. So the Vmax cannot be determined. If you were to determine the Vmax, would have to have infinite amount of substrate, which is not possible. So this Lineweaver Burk plot was devised, and it actually gives the information about the Km, Vmax, and the mechanism of enzyme inhibition. This is the Lineweaver Burk plot. On the y-axis, we have 1 over V naught, which is the initial velocity, and on the x-axis, we have 1 over substrate concentration. And negative x-axis, we have 1 over Km. The straight line, it intercepts twice. First, it intercepts on the x-axis, and when it intercepts the x-axis, it gives us the information about the Km. And then it intercepts on y-axis. On y-axis, it gives the value of 1 over Vmax, and hence we can calculate our maximum velocity value. The slope of the Lineweaver Burk plot gives us the equation Km over Vmax. We talked about that the Lineweaver Burk plot gives us information about the enzyme inhibition and how it does so. If we talk about the 3 types of inhibition, let us first look at the competitive inhibition. In the competitive inhibition, we can see that the intercept on x-axis is changed. Its value is actually increased because it was negative. So when it moves towards the 0 value, it is actually increasing. Hence the Km is increased, but the intercept on y-axis is the same. And it means that the Vmax is unaffected. Why Km is increased? Because the inhibitor binds to the active site and it decreases the affinity of the enzyme for the substrate. And the Vmax, why it is unaffected? Because of the fact that as we increase the substrate concentration, the effect that the inhibitor has on the Vmax is reversed. If we talk about the second inhibition, which is the uncompetitive inhibition, it is the inhibition in which the inhibitor binds to the enzyme substrate complex. And when it binds to the enzyme substrate complex, it reduces the Km value. So you can see that the Km on the red line is actually reduced and it goes more towards the negative value. It also means that it increases the enzyme affinity for the substrate, but it also decreases the Vmax, the maximum velocity of the reaction. We talk about the third type of inhibition, which is the non-competitive inhibition. You can see that the intercept on the x-axis is the same, but the intercept on the y-axis is different. And the intercept on the x-axis is the same because the enzyme, the inhibitor, binds to the enzyme on a site other than the active site. So it has nothing to do with the active site. So it does not decrease the affinity of the enzyme for the substrate, but it decreases the Vmax. Because even if we increase the substrate concentration and the substrate binds with the enzyme at the active site, the inhibitor did not bind to the active site. So the Vmax is reduced. This is how the Lineweaver plot gives us the value of the coefficient Km, Michaelis constant, the Vmax maximal velocity value by the intercept on y-axis. And it also gives us the information about the different types of inhibitions by looking at the intercepts on the x-axis and the intercept on y-axis.